I'm Anil Kumar. Welcome to my series on advanced functions. We'll discuss domain and range of radical functions, surds, or square roots you may call, in this particular video. We'll begin with the parent function f of x equals to square root of x, and then we'll take up few more cases. Sometimes we'll do domain range using the concept of transformations, and in the last two examples, we'll take up factoring as a case to find domain and range. To begin with, domain is all values of x which are defined for the given function. So let's take the very first function, which is f of x equals to square root of x. So this is the parent function which you can actually sketch, and then it's easy to see the domain and range of the function. At 0 it is 0, and then it keeps on rising as shown here. So you see from the particular graph itself that at 0 the value y value is also 0, and as we increase the value of x, at 1 it will be 1, at 2 it will be 2, square which is 4, so it will be kind of like this, and so on. So you can see from here that the domain of this function, let me write d of x, can be written as that x belongs to real numbers where x is greater than equal to 0. As far as the range is concerned, we'll write this as r of y. Y belongs to real numbers where y is also greater than equal to 0. So basically the function opens up in quadrant 1 and it is always increasing. So that is how this particular function is. Now let's move on and take the second example where we have a transformed function. So now we have the function f of x, which is written as 3 times square root of x plus 5 minus 2. Now you could actually sketch this function also and then find domain and range. So as far as transformations are concerned, we know that the function here plus 5 means 5 units left. And this minus 2 really means 2 units down. So as far as domain and range are concerned, vertical stretch doesn't really play much role. It is these two translations which really play the role. So if I am going to sketch this function, it may look like approximately 5 units left and 2 units down, something like this. Where the critical point to understand is this, which is at it has moved 5 units left and 2 units down. So from here, you can write down domain as equal to x belongs to real numbers where x is greater than equal to minus 5. As far as the range is concerned, we can write range is y belongs to real numbers where y is greater than equal to minus 2. Correct? So from transformed function, we can easily write domain and range. So as you can see here, other things which help you to find the domain and range is that nature of the graph. It opens up, right? And so it is towards positive infinity, and it has been translated 2 units down. So that becomes the lower limit of minus 2. And then the translation 5 units down gives you the left unit. As far as the domain is concerned, you could always find domain by equating things in square root to be greater than equal to 0. So that's another thing which which we are going to see in the next example. So let's move on to the next example and find some more strategies to work with domain and range. Now in this particular case, we are given a function which is f of x equals to square root of 2 minus x. Can you tell me the transformations in this case? Well, it's a good idea to always factor the coefficient of x, which is minus 1 in this case. And when you do that, you get x minus 2 within the brackets. And that gives you an idea that the function now is getting reflected on the y-axis and it is moving 2 units right. And therefore, the function will kind of look like this, where the point here, when x is equals to 2, it is 0. So that is at 2 and it is increasing. So from here, you can easily write that the domain of the function is now x belonging to real numbers, but x is less than equal to 2, since the graph has been reflected on the y-axis. As far as the range is concerned, it is y belongs to real numbers. There is no translation up and down, and therefore the range is y is greater than equal to 0 itself. Perfect. So it is important to note that when we have minus x, it is reflection on the y-axis, and that should be taken care of as shown here. Now, range is very important to look into, which is we have seen, but domain is critical. We could also find domain with an alternate method. So within the square root, we have square root of 2 minus x. We know that 2 minus x should always be greater than equal to 0, since square root of a negative number is not defined. So we could solve this inequality, right? So you could take x to the other side. So you get 2 is greater than equal to x, which means x is less than equal to 2. So that also gives you the domain by solving inequalities. Does make sense, right? So you could do this also as an alternate method if the question is to find the domain of the function. This is very effective and a shortcut method. Sketching may not be so simple all the time, correct? Let's take the next example, which is slightly different. This time we have f of x equals to square root of 4 minus x squared. How do we find domain and range of such a function? Okay, let's try to factor the inside term. So we get f of x equals to square root of, we have 4 minus x squared, which is kind of difference of squares. So I could write this as square root of 2 plus x times 2 minus x. The factor inside reminds us of a quadratic equation with x-intercepts at plus minus 2. Minus x squared means that the parabola is opening downwards. So actually, I could actually sketch this parabola as kind of like this. So this diagram here is of the inside function. The x-intercepts are minus 2 and plus 2. Clearly, for the radical to give you real values, we are only looking for the region which is within the positive interval. So that becomes the positive interval. So from here, we can write the domain of the function as what? X belongs to real numbers where x is greater than equal to minus 2 but less than equal to 2. Within these curly brackets which show the set of all real numbers. Now how do we find the range? Well, the maximum value here is 0. That should help you to find the range. So the maximum value in this case is what? Let's figure this out. F of 0 is equal to what? It is square root of 2 times 2, which is 4, and that gives you 2. So the maximum value is 2. So in this particular case, if I have to sketch the parabola, what do I get? I mean, the function itself, which is minus square 4 over x squared, what do I get? Well, we get a function which is a semicircle. So let me sketch this semicircle on the right hand side on a different scale. So what we will have here is a semicircle where the ends will be at plus 2 and minus 2 and the maximum value is 2. So that is the function which is square root of 4 minus x square. Clear? So we can get our range as equal to y belongs to real numbers where y is between 0 and 2, both included. Is that clear to you? So that is how you would actually write domain and range of this particular function. So here both change and you can see how we have figured this out. So that is a semicircle. This equation is of a semicircle. Now let's take another example where again we are going to factor. We have the function f of x equals to square root of x square minus 6x minus 7. Let's try to factor this. 7 is 7 times 1 and then you can get minus 6 also. So we can factor this as x minus 7 times x plus 1. Now let us try to sketch this particular function. So what we will do here is that the function which we are going to sketch first is within the radical sign, which is x minus 7 times x plus 1. So on a graph, it will be a parabola which have x-intercepts at 7 and minus 1. So you could sketch this kind of like this, where the points on the x-intercept are at minus 1 and plus 7. From here, you do get the domain of the function since the radical is only defined for positive values. So we can write the domain at least. So let's say domain of this particular function is when the function inside is positive, right? So we could write this as x belongs to real numbers where x is either less than equal to minus 1 or x is greater than equal to 7. Now how do you get the range of it? Well, the y values are always increasing as you can see. So in this case, you can easily write down the range and that is y belongs to real numbers. It is always greater than equal to 0. Correct? So that is how you could write domain and range of this particular function. So with that, we come to an end of this video where we have learned how to write domain and range of radical functions. It could change based on the transformations. As you have seen here, it is mainly affected by 3 types of transformations. One is reflection, the other is horizontal translation, which affects the domain, and then we have vertical translation, which affect the range. Reflection could affect both, depending on reflection is on the x-axis or on the y-axis. So it could affect both domain and range, right? So it could be on the x-axis and it could be on the y-axis, depending on where it is. So as a test question, let me give you one and then we'll close this video. Now, here is your test question. You need to write domain and range of f of x, which is equal to, let's say, 2 minus square root of 3 minus x. Feel free to write your comment, share your views, and if there are any doubts, share with me. The email address is given here. Thank you and all the best.